Hello, welcome back to part 3 of Neural Networks Explained. In this episode, I'm going to talk about one-hot encoding. Just a quick recap, the neurons in our input layer are populated by values via our data set, right? And we use random weights and biases together with those input values to calculate the values in the hidden layer. We run those values through the ReLU activation function, and then next we use a new set of weights and biases to calculate the values for the output layer. And the output layer, instead of using the ReLU activation function, uses the softmax activation function. And that just ensures that the sum of our values in the output layer add up to 1, as you see here. So that's the recap. So now we need to calculate our loss value. So to calculate the loss value, we're going to use something called one-hot encoding. This is also referred to as the error value. So one-hot encoding is a pretty simple concept. Each output value is assigned a value of 0 or 1. Actually, all the values are 0 except for the desired outcome. That one gets assigned to 1. So in our example, 6 was our desired outcome. And so we have this one-hot encoding list that has all zeros except for the one representing the desired outcome, which is going to be 1. And so there's two popular ways to calculate the loss value using this encoding function. The simplest and most straightforward one is that you simply subtract the output value. Actually, you subtract the one-hot encoding value from the output value. And then you get the result is your loss for that particular neuron. There's a second method that's a little more complicated, in which you calculate the negative sum of the product of each one-hot encoding by the log of the output value. I'm not going to use that in my example or in the code when we code this, but I just want you to be aware of it because it is a popular alternative. All right, so let's look at this in our example. So in our example, we have we simply subtract the one-hot encoding value right here. We're doing that from our output value, and the result is our error. And so these right here are our loss values, and we're going to use these to adjust our weights and biases using a method called gradient descent. And so we will do that in the next video. So in the next video we'll go through using these in back propagation. That's what that's called. I hope you found this interesting, and look forward to the next video. Thanks.